DeFi Slate team.
What's up, y'all? Real quick, if you like the DeFi Slate content on Twitter and YouTube and Substack, please give us a like and a subscribe on this video on YouTube. Join our channel, join the community. We'd really appreciate it. We're pumping this stuff out for y'all as much as we can, and we really enjoy the support and the community that we've built. Thank you very much and enjoy.
What's going on, guys? Welcome to episode 43 of the DeFi by Design show. It's July 1st today. Happy Canada Day. I'll have you guys know, both my parents were born in Canada, so I feel, very grounded today, right? So great day. DeFi's gone nuts. Crypto's gone nuts. It's a choppy market. Builders are going everywhere. People are going nuts. I mean, not really, but it's been exciting. And we're here to talk about some recent developments in the blockchain development space in terms of actually building and creating applications on the blockchain, what that process looks like. And we have the pleasure today of speaking with Dean Tribble. Dean is a blockchain specialist. I'm not sure if I'm gonna call him an expert because he might cringe, but I'm sure he's a self-labeled expert. And yeah, we're here today to learn a bit about what's going on over at Agoric and how they aim to impact the DeFi space. What up, Robbie? Welcome to episode 43.
All righty, buddy. Yeah, I'm doing well. Super psyched to be talking to Dean and the Agoric team. Yeah, it's been a great day. Very productive, very busy. Like you said, July 1st. Happy Canada Day. We're celebrating you today, Andy. I'm just kidding. Yep, let's get to it. Dean, how's it going? Tell us a little bit about yourself and a little bit about Agoric.
Well, it is going really well. Thank you guys for having me here. This will be a lot of fun. I got into large-scale secure distributed systems entirely too long ago. I worked on the first production smart contract back in 1989. So if you count, that's 5 years before Vitalik was born. It's important that blockchains predate, smart contracts predate blockchain by quite a bit. Now, I've been working with our chief scientist, Mark Miller, for a similar time period. He and I met at Xerox PARC Research Center, where we worked on these secure distributed systems and technology that was sort of the precursor to a lot of these distributed systems that you see today, including blockchain. So been working on this stuff a lot, really love the stuff. And for all of us, it's been about, it's been about supporting computer mediated cooperation, right? A smart contract is a thing that enforces a contract-like arrangement between third parties. So PayPal, Venmo, eBay, Airbnb, Uber, Lyft, those are all software running on a trusted third party. There's that word. But it's enforcing the terms of a contract-like arrangement between other people. And we were always very excited about that because we wanted to have computers help strangers cooperate, right? If you can create more cooperation, if you can make cooperation cheaper and easier, you get a more cooperative world. And that's always been kind of the driving dream in whatever it is, right? And if the result is you enable people to cooperate financially easier, get more strangers involved in their business and successfully cooperating, you get more economy, you get more efficiency, you get lower costs, you get happier people, you get people that, they might not like each other, but they're in business. So, what are they going to do, right?
Yeah. And I'm sure you've seen a strong development and progression of that exact concept over the last 20 or so years, huh?
Oh, yeah. Yep, yeah. Absolutely. Yes. However many flame wars are inspired by people arguing on the internet, the amount of cooperation that it enables far exceeds that. Right. I mean, much of the trillions of dollars of our world economy is all electronic cooperation by people who may never have met.
Yeah. Yeah. It's amazing how much value is created. And I think that's a very optimistic view, which is important to have and just really keeps you driving, keeps you going forward. Could you tell us, how you got to Xerox PARC, maybe what happened from there, and then ultimately what led you to Agoric?
Well, okay, it's a long journey because that was 1980s, right? So you,
maybe just the highlights then.
Yeah, Xerox PARC is where object-oriented programming was really promulgated. So Smalltalk was the programming language from which Java descends, from which Ruby was inspired. JavaScript was inspired. All these things come from the object-oriented model from Smalltalk. The UI, the user interface of the Mac, that was inspired by the Smalltalk user interface. So a lot of stuff started from there. And so, as a early, young punk developer, I really wanted to work in that stuff because it was just the coolest thing on the planet, right? And imagine a world with no windows and graphics. And now here's a place where you can go to work on that to both, play with it, build it, learn how it works, and get something out in the world that was meaningful, right?
It sounds like kind of creating something in the metaverse right now.
In the metaverse.
It's
That's
like,
right.
if you can buy and build a bunch of land currently in the metaverse, then you've got like, that's an analogy for what Dean is saying. Like, that just sounds nuts. Like there's no windows. Like, wow.
Right. No, it's a crazy time, right? So I went to Stanford, great university, but mostly it was so I could work at Xerox PARC, which was nearby. So I was an intern there. Anyway, somewhere along the line, I met Mark Miller. We were both in a project to do large-scale distributed systems, secure object programming and network communications with highly pipelined, high-performance messaging and all that kind of stuff. And so that work led into a bunch of the ideas that grew into, well, lots of things you see today. So for example, promises in JavaScript, the thing that people in Node, people in React, people in all these JavaScript applications use for asynchronous coordination, has a very direct lineage to that work that we did at Xerox PARC for doing asynchronous messaging and asynchronous programming. So a lot of interesting stuff came out of that. One of those is the Agoric Open Systems paper. So Mark Miller and Eric Drexler came up with a lot of these ideas out of the work we were all doing at PARC that really articulated software agents creating and participating in markets. And that led to a lot of the ideas that evolved into or inspired, the overall ideas of smart contracts. Nick Szabo came along from a different tradition and really had that idea in his head. And when he came in and saw what we had built in '89 and go, what you're doing there is this smart contract. That is the first production one. Let me tell you why that's important, right? And that kind of crystallized a bunch of those ideas of the realization that, yeah, having software that's in that coordinating and enforcing role is really powerful. And, and it's a different kind of business than things that had predated it, where it was, I'm a service, I'm providing you a service, you will buy the service from me. And that's fine and useful. CompuServe, I'm going to sell you email and you're going to be able to do email, right? Or a enterprise rent-a-car that I can go and rent a car from enterprise. And so they're running a service that lets me do that. That's great, but it's a different set of businesses that are enabled by empowering other people to cooperate with each other rather than just with you. And then, sorry, go ahead. You were going to say?
I'm on mute. So yeah, this distributed system, like you're saying, is a way to coordinate between people. Great. So I didn't mean to interrupt. Maybe you could just
so I'll add two
going.
or three more wrinkles here, and then we'll get we did a project for Sun Labs where Java was born, or near part of Sun, to do smart contracts. This was back in 1994, 96, something like that, where it was software contracts that were managing the selling of computational resources inside of computers. So cell processor time, memory, things that are now, controlled by gas, if you will, and learned a lot about how to be able to do that stuff. And so Mark then carried a lot of those, I was doing parallel systems research and then large scale production systems. I went off and built architected brokerage information systems for Schwab and electronic checks for IBM. And several of us did various disruptive technologies out into the rest of the world. And Markham was following the track of really driving that set of ideas forward, both our security model and how to be able to do smart contracts, how to be able to do interesting economic cooperation inside of normal programming languages. There's lots of ways you could do special DSLs or funky weird languages to be able to do this stuff. But to reach millions of developers, you needed to be able to do this in languages that millions of developers program in. So we both drove things into programming languages, Java, C#, C++, Tcl, everything else, and looked at what were the tools needed to do it, what would you like in a programming language for it, and so forth. So Markham came up with the E programming language. I was going off and building systems using the architecture for enterprise. He then jumped to Google, where they started the 𝗂𝗃 project, which was take those ideas that had been evolved in the programming language, where at financial cryptography, there are several papers that he has about here's how to do, you know, essentially an atomic swap in a normal programming language. Here's how to do a secure auction in normal programming language. And then he took those ideas of how to be able to do all that sort of stuff securely with components and started driving those solutions into JavaScript. So JavaScript was a, you know, security disaster, long ago, where many of the elements like strict mode and proxies and promises and all those things were driven into that with, you know, cooperation of Brendan, the guy who created this thing, and many others. But 𝗵𝗶𝗶 was one of the key forces driving those features into JavaScript, so that the JavaScript you use in Web 2, the JavaScript you use in Web 3, all of those have mechanisms so you can actually build secure systems. And so, you know, and then I went and took a bunch of these ideas over into a research operating system at Microsoft called Midori, where we made sure we can do this stuff for very high performance, very high scale systems. Okay, so that, you know, then I went off and did a payment instrument and got back into cryptocurrencies. Right. But somewhere along the way, I'll skip the steps where we were cypherpunks and doing crypto stuff, you know, back in the early '90s with all of the gang of other OGs. But so Sweet. I'll skip a few steps here. Come 2017, right? There had been all this crypto DeFi, and I was doing, you know, payments for traditional banks, which now turned into a multi-billion-dollar payment instrument. That was lovely. So I wasn't deep inside of the blockchain space at that time. And there were all these security breaches. And we had worked with Zuko of Zcash, �៊𝗂𝗋𝗃, and others in the crypto space because, you know, we'd been doing crypto stuff for a long time. And so they saw all these security breaches, whether it was the DAO hack or the reentrancy lockup of all the parity dollars or what have you, or the parity Ethereum, you know, all these things. And we're looking at that and going, and Zuko sort of asked the question, these guys know a different way of doing security. They've been doing this stuff for a long time. Do they have answers to some of these problems? And so there was a panel in 2017 that had Zuko, 𝗵𝗶𝗶, Arthur Brightman from Tezos, Brian Warner, who had just been working on the security review for Ethereum, Jorge, whose last name I will never pronounce correctly, from what was called the Gravity Project at the time. And it was about applying our security technology called object-oriented security, so object capability systems, to blockchain, and was there a marriage, right? And we got, you know, a lot of the people who had been doing this high security architecture, because it's used in secure OSs, we got a lot of them together, and we got some blockchain people together, and we did this panel. And it happened to fall just as Tezos was doing their sale. And so sort of from the beginning of the panel, or the beginning of the point where Arthur was speaking, to the end of the point where Arthur was speaking, they raised another $20 million in their public sale. So it's sort of a funny timing to have this all happen. But the outcome of that was, oh my God, this is a real solution to some of these problems. We should really do something about that. And so, you know, Zuko helped pull together the company, and thus Agoric was born. And so it then took a while to get it all together, but we had Brian as our lead crypto engineer. He had just, you know, fresh off of doing, he had done OCAP stuff. So our model inside of large scale, you know, storage systems, he'd worked with Zuko on zero knowledge stuff. He was an advisor to Zcash, and he had just participated in the security review for Ethereum, where he had identified the reentrancy bug that several people have been bit by since, that they didn't fix, but it was identified in that security review by Brian, right? So we had Bill Tullo, who was one of the economists that we had worked with on other endeavors and smart contract stuff prior to that, to help with the economic stuff. And so that was sort of the technical crew that got this started, that had the spectrum from, you know, software management, you know, systems, security, crypto, and economics. And that was the nucleus that we formed Agoric around. So that brings me to 2018.
So it wasn't until 2017 that you had really merged the object-oriented systems that you had, you know, worked on for 30 years. Not until 2017 did you bring that over to crypto and start to merge with some of the smart contract technology that Zuko, Brian, and some of these other guys were working on.
Right. Yeah. Yep.
Interesting. Cool.
I mean, the smart contract technology that I care a lot about is the stuff that was in the OO things. The thing that blockchain brings and the way it interfaces to smart contracts really is it brings high integrity execution, right? You've got hundreds or thousands of machines voting on what happened. They're all in different administrative domains. They're all in different jurisdictions. So no one can compromise enough of them to matter. And what that means is you can really rely on them to execute correctly and execute the code that you intended. And what that does, it lets you get rid of that trusted middleman, right? That, that trusted third party that is eBay that's going to do your auction. Well, now I don't need them, right? I can have the software do that, and that takes a big cost out of the middle, and it takes a big opportunity for someone to cheat out of the middle.
And so, is that unique of OOS or smart contracts, or does one of them have it and one of them don't?
No, that's really that addition of, there's what does a smart contract do for you? That's true of any smart contract. That's the whole point. And then what blockchain adds to it is being able to execute that directly without a third party. That is, that's independent of our security model. That's just fundamentally what that synergistic marriage of those two does, is it lets you now run smart contracts to enable cooperation. How good that is depends on the architecture of your smart contracts, but run whatever you chose to do on a platform that no one can compromise. And that's really the magic that makes smart contracts on blockchain powerful. Now, it's important to realize Bitcoin is a smart contract, right? It's software running on a platform that orchestrates a contract-like relationship between parties, where that contract-like relationship is primarily, I'll send you this money, right? Or, I will make this money available to anyone who can satisfy these conditions. And that's now enforced by the software. It's no longer up to me. I told the software it's going to enforce those terms. That's a smart contract. It's just a very specific one. Right. Ethereum added, hey, we're going to write it so third parties can submit these contracts and run them. And that's an awesome step forward, because now multiple people could add multiple smart contracts on the same platform and run with the high integrity that you didn't have prior to Ethereum and prior to blockchain. And so those are huge steps forward. Now, the question is, that model of smart contracts that you're running, does it have the power you need? Does it have security hazards that are too easy to step into? And the whole power of Agoric is it's a platform that has the power you need, is programmable in a language people understand, and avoids the security hazards that are endemic to Ethereum. And as a result, we end up with a model that is a lot more programmable to a lot more programmers. And if you're going to take over the economy with all this stuff, it takes more than the people in this room, or it takes more than the 10,000 developers that can maybe write a decent contract on Solidity. It takes the millions of programmers that do financial stuff right now. Pretty much, they all know JavaScript, right? So 10 million programmers know JavaScript. We can have smart contracts that are readable to pretty much all of them, and readable to new programmers with 3 or 4 months of training. And that's what you need in order for this to get bigger legs.
And that just pushes the coordination to just a whole nother level, right? You got the 1-2 punch of the smart contracts and the blockchain. And then now if we can create the thing that I think the entire space is missing, which is basically just like ease of use. Like earlier today, we were speaking about the UI experience, right? As these prices are down, everyone's like, all right, what can we nitpick to fix, right? But that's how building happens, right? And so now it's like, okay, if we can get one of the biggest programming languages in the world known to mankind, exactly, onto what we're trying to accomplish in terms of decentralized systems, then we've got a bigger bowl to choose from effectively, and in terms of innovation that speeds it up. So I'm curious how you see the impact of bringing JavaScript to the blockchain, if you will, or to the DeFi scene.
Absolutely.
Will impact the overall coordination of the space and of the industry. How do you see it affecting the
So I'll make a JavaScript analogy for user interfaces in JavaScript. So 15 years ago, developers could struggle to build kind of cool UIs in JavaScript. Now, the language has certainly changed since then, but not sort of in some fundamental way. It's got DOM compatibility back to the dawn of time, right? And now a beginner with relatively little training can make an application that is responsive, internationalized, flashy graphics, works on multiple devices, including mobile phones, and looks better and feels better than what an expert could do 15 years ago. And the reason is not because the language is different. It's not, here's JavaScript, knock yourself out. The reason is because there are frameworks in which there are a definition of components. So let's take React.js in particular, but Vue and Angular and several others recent frameworks have the same properties, where I can define, where there's a defined way that components are built and plugged together, and a framework that will use them and that provides affordances for doing user interface interaction. So it knows how to help rendering. It's got support for styles. It's got interactivity. It's got, all of the gesture stuff formalized as events, so it's easy to program those events. And then there's patterns to follow to be able to build these things. And that's what we call a real compositional model. People in crypto have been talking about composition. That's what real composition is. It's where I can take a component built by someone else, parameterize it a little bit, plug it in, and use it as is, right? And that means a beginner can take a slideshow and take a library from Stripe and add a little bit of code, and now they've got something that's selling their images. And that's accessible to a programmer, someone who's got a little bit of programming and is otherwise an artist, and now they've got a site that's selling their images, right? And they can do that quick, even though they couldn't build a slideshow or build a Stripe thing. Yes?
Is this level of composability out of scope for Solidity and Ethereum? Yeah. Or is it just simply that the skill learning curve is not there yet?
So it is. So in general, composition on Solidity is so hard that all of the cases where it happens are really notable, right? A lot of people, we like to talk about, Compound's governance contract being used by Uniswap to produce the Uni thing, which was a huge success. We don't like to talk about the fact that dForce did the same thing and lost $25 million, right? Code copying is not a good way to do composition. And the security model of Ethereum fundamentally obstructs this ability to easily plug together components. When I'm building my UI and plugging in a slideshow, it doesn't ask, so which user is doing this? Are they allowed to see this image? I don't know, right? Instead I go, here's the slideshow, here's the image, do it, right? And there's no questions. It can only show the slides I gave it, and it can show exactly the slides I gave it, and it can show them in the screen area I gave it, and that's it, right? That's the model, right? And that model of components that can plug together is really, really powerful, and the security model of Ethereum gets in the way of that. The whole, the details kind of don't matter, but people have tried lots and lots of things, and they keep adding epicycles, and it keeps getting more complicated, and it adds performance, it adds gas, and it doesn't solve the problem. So,
and a fair answer for why one would choose to basically use a different set of code and parameters than on the Solidity blockchain. However, we have to understand here, please.
Oh, I was just saying, and so people do composition, right? No question, Ethereum is hugely valuable. It's just really painful and expensive,
right.
And it's
in the current.
Risk.
It's in the current, right? So it's like, what is DeFi? It is Ethereum.
That's right. Well, no. So Cosmos is getting a lot of DeFi. So we can talk about that. But
on this show, we're kind of like, all right, let's be real. It's Ethereum, but we're not.
Absolutely.
A multi-chain world is going to be
inevitable,
right? And all these things are going to come into this. All these factors which you spoke of are going to come into the picture. And there's different little rules and parameters and sets and things and everything really for each chain. So in particular for how the JavaScript blockchain will work, how will I guess in the most technically sound way, which you can describe, but also easy, how will the JavaScript-esque blockchains create and validate transactions, and how will the node infrastructure look?
Okay. So fundamentally, whereas on Ethereum you're running an EVM and it's running a particular instruction set, we're running a JavaScript machine on every node. Now, our technology, we have a security technology called SES that lets us lock down JavaScript. So, people sort of have this racial memory of JavaScript as being insecure. And that's because it's malleable, right? It turns out it's really valuable to have a system that can evolve where I can change what array iteration does, what array for each does. It's not so great if I can change array for each to iterate all of your information, go open a file that has your secrets and send them off to another country, right? That's not so great, right? So, so in some sense, building systems on JavaScript right now is like building on quicksand. And what our lockdown does is it really turns that into concrete. So it locks what all those primordial objects are. And so as an accident of history, JavaScript is actually more securable than most other programming languages. We lock down the world, and now we can run confined programs in arbitrary JavaScript, arbitrarily malicious JavaScript, inside of a compartment where it cannot get out. right? And this is all based on SecureOS technology, architecture from SecureOS technology. We understand that very deeply. We've done it in multiple systems, and it's a really awesome, awesome technology, right? And and it's used in Salesforce App Exchange. It's used in brokerage terminals. The next generation of MetaMask wallet will be using it for its extension module, right? This is a technology that lots of people have looked at. Parts of it are in the node security architecture. It's changing how modules will be done in JavaScript and so forth. And so that lets us run safe programs in JavaScript. Okay. So then every validator node, right? And this is a proof of stake network. We're building a proof of stake network on top using Cosmos SDK. So it's Tendermint underneath for consensus. And then we run our stack on top of that. So every validator node is running a JavaScript engine that for every smart contract that's running, it's running that contract in one of these confined boxes. And conceptually, it just stays up and keeps running and just runs in memory, right? Now, there's a lot of magic so that that's what happens conceptually, but in fact, if it crashes, it'll come back up in a few seconds and keep going. You know, it's storing it out to disk as these, you know, okay. And so at the same time, we can lock down that execution so you can't escape the box. We can make it so that it's deterministic. So what we're really running is deterministic JavaScript so that once Tendermint has accepted a transaction, now all of the validators will execute that transaction, the message that comes in, like bid 1,000 𝗏𝗏𝗀 in this auction, and it will execute them the same, come up with the same answer to take 1,000 𝗏𝗏𝗀 out of my account and put it in the auctioneer's account and decide the same thing at the end of the block. And so what that means is if a machine crashes, I mean, conceptually, it can just, it'll get back to exactly the same state. And anyone can look at a block and go, what happened there? And they can just start the block at the beginning, run the messages, debug them in a normal debugger, inspect what all the variables are in JavaScript, and get the same answer as the chain got in order to see what happened, right? And so that's sort of the computational model. And so what that means is every block is these messages were delivered. We have an initial state. We compute a new state, you know, and a set of messages to be delivered the next block, and we're off to the races, and that's your blockchain. And so,
and you call this a deterministic blockchain?
Yes, absolutely, absolutely. Yeah. So in order to have, you know, independent computers running running the same smart computation and being able to check each other's work, it's got to be deterministic so they come to the same answer. And so, you know, Ethereum's model is deterministic, Cosmos is deterministic, Tesla's deterministic, you know, but we managed to be able to bring exactly the required determinism without having to write a special programming language that has that characteristic. We were able to bring it to one that people already understand. And so being able to bring that to the JavaScript was part of the coup of what we managed to do here.
Yeah, yeah. And, you know, you called it coup. I was going to call it secret sauce. Like, what is the special, you know, twist that you put on a blockchain that makes it different and just better than, you know, the unique advantages over other blockchains that are out here? What is your secret sauce?
Okay, so well, there are two levels of this, right? There's the execution model, and then there's the economy we're building. At the execution model level, it is that security model of object capability security, where you know, there's a lot of theory about it. Secure operating systems were built on this design, SEL4, you know, the most secure OSs on the planet were built this way. And there's lots of detail to getting it right in an operating system. And, you know, like underneath we have the Agoric VM is essentially an operating system. There's a lot of tricks to getting it right in a network protocol, but fundamentally at a programming level, it just shows up as object-oriented programming. So I've got a concert ticket object. I've got a reference to Andy. I can say Andy.enjoy concert ticket. You know, that's a JavaScript one-line sentence. Here you go. And now my concert ticket is handed to the object that Andy gave me to deliver the concert ticket into his inbox. And that's it, right? I have the object, I hand it to him. It's just like I give him my car by handing him my car keys. He gives it back by handing them back. Very simple to understand. Actions that transitions that I take are automatically changing who's authorized to do what without it having to be, okay, I need to add him to the list that's authorized to drive my car. And when he gets to the hotel, he's not in a position to add the valet. So oops, he's got to park his own car, right? So that model, I mean, we've got lots of presentations that go into it. That model is what enables the kind of composition that developers are used to when they're building Node.js applications, when they're building React.js applications and so forth. It's the thing that really has the leverage where, I mean, literally, you get to build on, you know, what is it? Not literally, you get to build on the shoulders of other developers. So literally it leads to the exponential growth of components and the exponential ability to rapidly build, new DeFi applications or new dApps. And that exponential growth is what we believe will overtake the development speed on other platforms simply because they're not in a position to be able to reuse components in the same way. And that's a huge lever point. It's the reason why, React and frameworks like that took over the world of doing user interfaces in JavaScript. It's the reason why Node.js crossed 1 billion downloads a couple of years ago, right? Because people use it for doing large scale network systems and so forth. And so it's a huge lever point. So that's a big comparative advantage. Now, we give away a lot of that technology, but it's integrated into our chain and we understand that model in a way that others don't. And so we help people use that model for other things, but our focus is our public chain.
And that's the execution layer.
Yeah. Mm-hmm.
And now that's part one. And is there a whole nother layer to like this economy layer, that brings up more value?
Yep, absolutely. So the other, so there are two more layers that are important. One is our smart contract layer, and then the second is what we do with it, which is our economy. We refer to it as Zoe. If anyone's seen Firefly, no, it doesn't refer to that Zoe at all. No. But it is a framework for doing smart contracts where you mentioned the horrors of user interfaces in current crypto ecosystem. I characterize that as send money to a random number and hope something good happens. Right, you go through all this lovely UI and then you push a button to swap and it says, transfer, 4 ETH to 0x99532, and I have no idea, right? So for us, instead, the intrinsic model of smart contracts is I make offers to them, right? There's a quid pro quo. I give an offer of, I will offer you, God, I don't even know the prices, right? I will offer you 300 USDC. How's that? for that particular concert ticket. And now I've contributed my 300 USDC to the contract, but it's not available to the contract unless the contract provides the concert ticket. And so the contract infrastructure is enforcing that what I give you, you only get if I get what I want. And if
so
you
like
can't provide that, I get my money back.
It's like granting the permission that when both objects are present, that's when the switch is made.
Right. It's what the financial industry calls delivery versus payment, where I'm saying I'll give you this, but it's going to be escrowed by the contract system until you provide the other thing. And then, the seller on the other side is doing the same thing. I'll give you this concert ticket if I can get $250, right? Yeah. And now we both presented that to a smart contract in the middle that's running an order book, and it goes, you two, let me reallocate your money to him and his ticket to you. And now, bam, the sale consummates and everyone goes away happy. But an important thing about this is it's what we call offer safety. No bug in that intermediate contract can cause me to lose my money unless I get my concert ticket, and vice versa, right? And no bug in that intermediate contract, whether it's malicious or accidental, no bug can lock up my money indefinitely. I have exit assurance, so that what we call exit liveness, or payout liveness. That's what it is. I will get my payout. So if I say, give me my money back, nothing the contract can do can stop it from rescinding my offer and getting my money back, right? So the level of economic safety this provides, and also as a contract developer, the safety it provides me where I can't accidentally have a bug that steals everybody's money, that's just a huge, huge value, right? It's just a vast reduction in the overall risk of uninteresting bugs. I'm perfectly happy for people to deal in economic risk where they're playing interesting games in finance, but having them subject to computational risk, that's terrible, right?
Yeah, okay. Yeah. So you can still be rug pulled, right?
That's right.
There's still economical risk. Someone pulls their liquidity and you can't swap out and cash out. But like you're saying, there's no computational risk of a bug, malicious or otherwise, that just happens to be an error in the code. And
you can't have a rug pull that just leaves my money stuck. If you have an escape with my money, I can get it back guaranteed. And if I see that happening, and now it's a race to the line to get my money back, but nothing the program can do can stop me from getting my money back if it's still there.
Have you called good old the owner of the Mavs, Mark Cuban, about that one? I think he's interested. I think he got rugged on iron.
That's right. Yep.
Give him a call.
Well, parity, right? The reentrancy bug of parity, that's an example of a bug that simply should never have happened. That should, we like safety properties where it's stuff that never should be possible. Programmers shouldn't be able to express certain kinds of issues. Reentrancy is one of those.
So there was no hacker in that parity loss. It was just a drain of funds that kind of ended up in the ecosphere.
Well, it was that someone actually broke it, whether it was a hacker or accidental, who knows, right? But the result is there's a bunch of money locked up in a contract that no one's in a position to pull out, which means they don't have payout liveness. They aren't able to get their payouts. It's clearly their money. Well, except by virtue of the code, no, clearly it's not, because they can't do anything with it. So, what does it mean to possess it, right?
Yeah.
So that's at the smart contract layer. At the economy layer, so our mantra is build fast, earn fast, right? Being able to build in JavaScript, being able to build with other people's components, being able to build with some of the best development tools on the planet, VS Code, WebStorm, et cetera, and use standard CI and development practices and all the JavaScript static analysis tools, and get types from TypeScript and all those kinds of things, and all the literally millions of libraries out there inside of your smart contracts. That gets you the build fast part. But the earn fast requires a place to deploy this stuff. Obviously, the main place for deploying DeFi right now is Ethereum. It's, 6 months ago, I would have said it was the only place, right? But now with the advent of IBC, the Inter-Blockchain Communication Protocol, we've already seen multiple networks starting in the Cosmos ecosystem where they start connected to each other. So, Osmosis launched and people brought atoms over and invested it immediately, right? And so it was garnering $10 million a day in additional capital. Now, I realize that's small potatoes compared to the DeFi Central of Ethereum, but all new oak trees start from an acorn, right? And this really is a very important shift that Agoric will take advantage of, which is when we deploy our chain, when we go public, when the public chain launches, it will launch not in a vacuum, right? It will launch connected to tens of billions of dollars on Cosmos, Terra, BNB, et cetera, right? All these IBC connected chains. Okay. So it's kind of being a place, but it's not quite there yet, because you can launch a chain, but you can't just deploy a smart contract. So we are producing that smart contract layer where it's the market, right? It's an economy, and it has the ingredients so that you aren't just saying, here's a programming language, knock yourself out, or even here's a framework, knock yourself out. Here's a place where once you build it, you can go and deploy it and have there be money, have there be stable currency, so that, everything's priced in the same terms. So a customer coming can go, do I want to buy that hedge, and versus that insurance product, right? And I don't want to be going, and that one's 4 𝗏𝗏𝗡s and that one's 23 simoleons. Which one's higher? I don't know. I've got to do currency exchange in my head. That's crazy. You can clearly make an economy work that way, but it's expensive. It's sand in the gears. It means evolution. It means innovation is harder. And so what we have is a stable local currency called Run. So it uses a CDP style model, a vault style model, but it's intrinsic to the economy, right? It's backed at the end of the day by the underlying staking token. The crypto, the stable local currency is what contracts will use to pay gas. So gas is now charged in you can compare its cost from day to day because it's charged in a stable coin, right? And it's the glue it's the grease that makes trading and pricing across these different contracts easy. And then we have a native AMM that when, it's an asynchronous system, it can wake up in response to pricing events instead of waiting for someone outside to go, oh, the price changed, right? And so when the vault notices that some vault is underwater, it can wake up and turn around and proactively sell it on the local AMM. Or rate limited and have it sell incrementally over time. So there's time for arbitrage out to Gravity Dex or Osmosis or Thorchain or whatever to be able to dip into those other liquidity pools in order to make sure that the price stays, reasonably constant, not just on the chain, but over the overall interchain ecosystem.
Right.
And so that's what we're building, is a place where you get all those services and where it's easy to be able to integrate and compare multiple businesses. And that means that you can add new little businesses, right? You can add something that all it does is stop loss on an AMM, and it's, 20, 30, 40 lines of JavaScript that anyone could understand. And now it's a business and I can deploy it. I can deploy it on top of an existing economic model, right? I can build a business where, a new DeFi thing where it needs liquidation, but I'm not a liquidation specialist. I'm going to grab the same liquidation the underlying engine uses. I'm going to grab the governance implementation, exactly a component, right? NPM install chain governance, right? But instead of using the underlying build token, BLD is our staking token, instead of using that, I'm going to use my liquidity token. And I don't have to do that by changing the software. I just do it by instantiating it with a parameter that says, vote based on my token rather than his token. And that means I'm using a battle-tested, hardened, reviewed, insurable component plugged into my thing, and I get to focus on just my business and deploy something fast, and in order to start making money based on my comparative value. So.
In that economy too, that's already created as you as a developer, entrepreneur, or just person in general trying to go and create too. Now I know this strikes a ting with Rob and I, because we've had thoughts about, oh, okay, I want to learn this language and build this. One big thing that you actually hit on was like a liquidation bot. Like that just sounds awesome in terms of profitability,
yep.
morality, and such. We can get into the philosophical later, right? But the point is that ability to get up, go, build in a short amount of time is key. Now, I kind of want to turn the convo over to the intricacies of the DeFi economy, right? So we've got all these fungible tokens and all these pools of liquidity, as you're saying. So, right, you can go and trade on an AMM, you can deposit into this protocol, you can trade options on this. So a lot of the financial characteristics that you're explaining in this economy are created. Now, where do the concept of non-fungible tokens fit into this DeFi world that you explained, right? So obviously we understand what those are. For those who are new to NFTs, what a non-fungible token is effectively, it's a token that cannot be easily replicated, if you will. Now I'm going to let Dean give a more technical explanation, but effectively, one Bitcoin is one Bitcoin, but my house is not your house, right? And so that's kind of like the idea. So I'll let Dean explain NFTs and perhaps a little bit of insight into, while it is early, but how they could fit into this idea of your economy.
Okay, so a big part of this is, I talked about Zoe, the contract layer. There's a thing we call electronic rights transfer protocol, which is an API for generally being able to talk about digital assets. That includes fungible assets and non-fungible assets. So non-fungible assets are intrinsic to our system. All of these abstractions, whether it's escrow, whether it's the Zoe contracts, whether it's the auction contract, it can be auctioning off, fungible, ETH from a liquidation that's pegged across IBC and over the gravity bridge to Ethereum, or it could be auctioning off a CryptoKitty, right? It's exactly the same kind of asset, and that same tiny little JavaScript program that I could explain to a beginning programmer, it works across native tokens, synthesized tokens locally, NFTs created, fungible tokens, remoted tokens, bridge tokens over pegging networks. All of those things can work uniformly. And that's one of those advantages of having, for example, taken asynchrony as sort of a fundamental reality of the world, that the decentralized world, the world, is islands of synchronous computation in a sea of asynchronous communication. All of that model I talked about doing escrow, I can deposit something where in order for it to get escrowed, there'll be asynchronous communication to bring it all over and lock it up. So now the smart contract knows that the offer has good funds that are locally available. And so adding an NFT in our system, well, it's 2 lines of code, right? There's an example of that we go through of, taking a loan where we transfer money, we transfer ETH through the gravity bridge over IBC onto our chain, create a vault, take a loan against it in stablecoin, go off to the baseball card store and buy an NFT baseball card. And all of those are written in JavaScript. All of those are reusable components, and they're all straightforward for people to build apps with. And so being able to add new NFTs, piece of cake. And all of these abstractions will work with it. If you want to, if someone wants to end up creating a loan instrument where you can take loans against NFTs, that's just instantiate our vault mechanism. Tell it here, these issuers are ones that you should be willing to accept. Here's the oracle for them. It follows the same oracle thing. And it may actually, may plumb into like Chainlink oracles that go off to markets to see what those NFTs are trading for. And now the same vault thing will let you take a loan against an NFT. And so a lot of these mechanisms all exist.
Yeah, and the ease of use that you're explaining and the practicality, it makes me think that you are pretty confident in the ability and the longevity of NFTs in the decentralized kind of world.
Yeah. No, I think
here to stay.
To me, NFTs have just barely started. Right now, the easy ones people talk about are basically autographs, right? Where the autograph copy of some digital image is more valuable the more people have seen the digital image. But the whole evolution where it gets into, I've got an assurance that I'm part of some experience, right? You know, like a musician that shows a QR code that everyone that sees their first live performance of this song can scan that QR code and forever be able to show that they were there, because it's got a geo positioning thing using some other crypto mechanisms in it, and that lets them download and play that song whenever they want, or lets them share in the ongoing revenue of that song, or whatever it is that it gives a hook to be able to get ever increasing engagement. And that's one of those things where going forward, that's a place where I expect a lot of innovation, right? You know, because it's not just autographs, it's not just this fad thing. It really is this mechanic for engagement of stuff created with participants that want to consume it, or creators with the people that consume it, or what have you. That's just a powerful way that people cooperate. Orchestrating cooperation is what smart contracts are all about. And this is an area where I expect a lot of innovation. And so being able to build fast and deploy and earn fast is kind of crucial. And the other thing is, all those people out there that do these sexy, awesome graphics, gaming,
The
music,
artists.
all those sites, yeah, they know JavaScript.
They can
our goal
know
is
it.
if you can build an application in Web 2, you can build the decentralized one in Web 3, right? And on Agoric. And so so those people are welcome.
And a quick one here. What are 2 or 3 applications of NFTs that you think are perhaps a little far-fetched, but could work?
Well, so we've seen several, right? Collectible trading cards. I like finding ones that are far-fetched is hard, right? Because that one's got, I don't know whether it's quite got product market fit, but it's really close. There's clearly a thing there, right? And so that's a valuable one. Digital collectibles of real artists, and in particular of performance art that is otherwise not collectible. That seems like it will have legs because there's a lot of, people want to consume that. There's a lot of drive for the artist to be able to produce it, and they've had trouble monetizing. Well, one of the things that crypto has done is found very new, great ways to monetize stuff that would be underserved because it was a public good, right? It's been able to monetize open source software in a way that no one was able to do heretofore. Being able to monetize performance art, more power to them. So that's a huge one, and that extends into music and just vast amounts of participation there. So I think there's a lot of legs.
Ownership, big time.
Yeah. Yep. Well, and participation, as I said, engagement, right? And it might be that you're going to put on a concert, you're going to produce a song. I'm a fan, I want to help promote it, I want to get people there. And as a result, I get a very teeny share of the bar tab, right? I actually might economically participate in helping to promote the thing that I want to do and love, right? All the things that people do to participate in gaming with Twitch and Discord and all those sorts of stuff. That's tens of billions of dollars in consumed value by lots of people there. So
yeah, the business applications of NFTs are certainly an aspect of it, and just points to the economy layer above the execution layer that you mentioned. The most attractive thing, one of the most attractive things of the type of system that you described is the composability. And kind of these plug and play lightweight type of modules that you can just combine, right?
Yep.
What is the integration? What is your vision of the integration as you continue to build this out? Is there going to be DeFi Legos 𝗷𝗶𝗆𝗆 that are built on Ethereum now just deploying on Agoric, or is it going to be brand new applications that are built on top of Agoric? Right. Does it happen right away, or does it take some time? What does that look like?
Right. So I'm going to give you a very quick answer, and then I want to point out Agoric is hiring, and I've got an interview in 1 minute. So unfortunately, we have to wrap up, and I'm happy to come back and talk some more. We start with a native AMM based on similar kind of technology. We start with a native vault mechanism, but we expect some of those people to come build their equivalent business on our system because they understand the business. Our goal is to promote a large growing economy, not to be, we're not trying to be the Compound. I'd be delighted if Compound came and built on our stuff. I'd be, delighted, but less so if all we do is we bridge over to their chain and the two interoperate that way using IBC. And if someone else comes and builds what Compound does on our system, you know, using a different name, that'd be great, right? So I expect a lot of these things to be built and build on each other and use components on our platform. And so the thing is, you know, the stuff that people suffer over to get this stuff done in Solidity, you know, we know it's 4 to 5 times faster to build the same thing in JavaScript, even before you take into account security reviews and availability of programmers and all that sort of stuff. And so reproducing a lot of that stuff, you know, we're really at the beginning of all these things. I'm not afraid of how much people have built there because frankly, it's amazing stuff. It's wonderful. And we still haven't gotten very far. So I'm excited about what that future holds. So.
Well, we appreciate you, Dean. We won't be late for your interview, so take it easy. Super excited to talk anytime more that you have. So
great.
Thanks for coming on.
Thank you for having me, and we'll talk soon. Bye.
Great. Smart guy.
Fucking got hit by an earthquake. That guy.
Wow, fucking earthquake.
Fuck yeah, it was a fucking earthquake. Yeah. Woo! Fuck yeah! Bro.
Yeah, that guy knew what the fuck he was talking about.
I'm saying.
Stop that recording, why don't you?
Yeah, it's been stopped. All right, file export MP3. Oh, the Zoom.